Okay, picking up from the last video, we did some hypothesis testing, but we used a critical value approach. That is, we calculated a critical z or t, and then a computed test statistic z or t, compared the two to determine the decision. Now we're going to do hypothesis testing using a p-value approach. And there's going to be 4 steps to this. The first 2 steps are the same as the critical value approach. But let's go through an example. It says a social media website that caters to younger demographics claims that teenagers in California spend around $50 per month on coffee at Starbucks. To determine if this claim is statistically accurate, a UC consumer economist conducted a survey of 64 teenagers in California. The sample average was $53.10 with a population standard deviation of 10. Test the claim at a 0.05 level of significance. Okay. The first step is null and alternative hypothesis. Our null is going to be an equality here because notice it says that the social media website claims teenagers in California spend around $50 per month, so equal to $50. In other words, if we got a sample that was really high above that number 50 or really low below that number, we might have to reject the null. So we use null equals 50, and therefore the alternative is not equal to 50. The level of significance is given to us at 0.05, so we just put that in there. Now we're going to calculate a p-value, but to do this, we do need to find a computed test statistic. So it's going to be z because we have the population standard deviation. If we didn't have that, we would use t. We then take the sample average of 5310, subtract it from the hypothesized average of 50, and divide that by the standard error. If you do this correctly, you'll get 2.48. Next, we convert this computed test statistic into a p-value using either Excel or our tables. Let's go ahead and use the tables first. So we have 2.48 as our test statistic. So we're going to go to 2.4 and over to 8. That gives us a 0.9934. Going back, the p-value is going to be the opposite of that. So we're going to take 1 and subtract 0.9934. And if you do that, you get 0.0066. Because this is a two-tailed test, we're then going to double this value, and that will give us 0.0132. That, therefore, is your p-value. You then compare that to the level of significance of 0.05, and if you get a value that is less than the level of significance, then we can reject the null. If you get a value that is greater than the level of significance, we cannot reject the null. Here, we got a value that is less than the level of significance, so we reject the null. In essence, the p-value tells us the probability that this particular sample mean or greater would occur if the true population mean were 50, which is the same as saying that this z-score of 2.48 would occur if the population z-score is 0. So it's telling us that this region up here is 0.0066. Well, that's below the 0.025 that we use to define our rejection region. Moving on to the next application. A spokesperson for McDonald's suggests the average work week for their workers is at least 25 hours per week. To test this claim, a sample of 40 workers were randomly selected from all the McDonald's stores in San Diego. The sample average work week was 23.4 hours per week. Assuming a standard deviation of 6, test his claim at a 1 or 0.01 level of significance. First, we state the null and alternative. Well, for the null, we're looking for an equality in the narrative. And it says here that the spokesperson suggests the average work week for their workers is at least 25 hours, which means 25 hours or more. So that becomes our null, greater than or equal to 25. That defines the alternative as everything else, less than 25. 2, the level of significance, our alpha, it's given to us. It's 0.01. 3, calculate the p-value based on the computed test statistic. Well, we have a sample of 23.4 hours and a hypothesized mean of 25 hours. So we find the difference and divide that by our standard error, which is just the standard deviation of 6 divided by the square root of the sample size. If you do this correctly, you should get negative 1.69. Of course, it's negative because we found a sample mean that is less than the hypothesized population mean. Now, we need to convert that into a p-value. We can do the tables or we can do Excel. Let's do the tables first. We're looking for 1.69. Scroll down to 1.6 and across to 0.9, and we have 0.9545. Now, we know that we need to subtract that from 1. So we're going to take 1 minus 0.9545. Let me go ahead and use Excel for this. And you get 0.0455. That is our p-value. We don't need to double it. And the reason is because we only have a one-sided test here. This is a lower tail test. Okay. The p-value is greater than the level of significance. So we cannot reject the null. Remember, it has to be less than the level of significance to reject the null. You can see this here. We are hypothesizing that the mean is greater than or equal to 25. That's the contention that McDonald's spokesperson is saying. So he's essentially saying that the mean is up here, right, above 25 or at 25. But we go out and we collect a sample and we get 23.4, which clearly is in contrast to what he's contending. But that doesn't mean that he's wrong, because statistically 23.4 could be close enough to 25 that the true population mean could actually be over here. That's why we need to do our computations. We convert this 23.4 sample mean into a z-value. Then take that z-value and convert it into a p-value. And that will give us the area that's in this lower tail here. Okay. So there is a 0.0455 chance of getting a z-value of negative 1.69 or less. There is a 0.0455% chance of getting a sample mean that is 23.4 or less. But remember, our level of significance was 0.01, which was this region here. Because the probability of getting this mean in a sample, this z-score from the sample, is greater than our level of significance, we cannot reject the null. So the spokesperson could be correct that the true population mean is greater than or equal to 25, that the true population mean is in fact somewhere over here, because our sample mean is not really far enough away from it to reject. Okay, let's do another one. This says the County Board of Supervisors is selecting a new paramedic service. One of the most important criteria in the selection is response time. The just-in-time paramedic company claims that their average response time to any call is at most 12 minutes. To test their claim, 50 of their last year's calls were selected at random. The mean response time of the 50 calls was 13.3 minutes, with a standard deviation of 2.6 minutes. At alpha of 0.05, what can the board conclude about average response time? First, we set up our null and alternative. The way this is phrased, it says the just-in-time paramedic company claims that their average response time to any call is at most 12 minutes. Well, that includes 12 minutes, meaning there's an equality there. So that's going to become our null, right? They're contending that it's less than or equal to 12 minutes. From that, we define the alternative, the opposite, which would be greater than 12 minutes. Level of significance, alpha, is given at 0.05. Next, we find our p-value based on the computed test statistic. Take the 13.3 sample mean and subtract the 12 hypothesized population mean, and then divide it by the standard error, which is our population standard deviation over the square root of our sample size. If you do this correctly, you should get 3.54. Now, that needs to be converted to a p-value. We could do this with the tables, which we've done, but we can also do this with Excel. In Excel, there is a function we've used before. It's the norm.s.dist. Okay. Pull up the argument box, and it's going to give you the same thing the tables do by plugging in a z-score. We're going to put in 3.54, and we put cumulative, which again gives us 0.999. Okay. So we know that we need to take that number and subtract it from 1 to get 0.0002, which is our p-value. We don't need to double it because this is a one-sided test, an upper tail test. Okay. Because our p-value is less than our alpha, level of significance, we reject the null and therefore conclude that the response time is not less than or equal to 12 minutes and is most likely greater than 12 minutes. Now, we can also look at this in our diagram here. Remember, this is a right-tailed test because what is the null telling us? It's saying that the response time is less than or equal to 12 minutes. Okay? But we collect a sample, and that sample mean shows that we actually are up here at 13.3 minutes. Now, the question is that so far away from 12 that we reject the null, that the response time is less than or equal to 12 minutes? Well, to determine that, we need to convert to a computed test statistic. 13.3 lies 3.54 standard errors above the mean. And this 3.54 corresponds to a p-value, which is this area up here in the tail, of 0.0002. Well, our rejection region is if we had anything up to 0.05, our alpha, and we got 0.0002. So the 13.3 or 3.54 z-score is so far away from the hypothesized 12 z-score that we reject the null and say that it's unlikely the true response time is 12 or less when our sample is up here. Another way of thinking about it is you would get a sample mean of 13.3 or greater less than 1% of the time, but we would reject the null if the probability of getting a sample was less than 5% of the time. Okay, that's it for this video. I'll pick up in the next one. Thanks.